Welcome to JD's Prep. In this problem, we're told that at the present time, Mrs. B's age is 6 years more than 4 times her son's age. 3 years ago, she was 7 times as old as her son was at that time. If B represents Mrs. B's age now, and S represents her son's age now, we want to start by writing a system of equations that could be used to model that scenario. So what we're trying to do here is we're trying to use the information given in those two sentences to create a system of equations. The first equation tells us that Mrs. B's age, which is B, is 6 years more than 4 times her son's age, which is S. 4 times her son's age is 4S, and 6 years more than that, we add 6. And that gives us Mrs. B's age, which is B. In the second sentence, we're told that 3 years ago, in other words, 3 years less than either of the two current ages, she was 7 times as old as her son was then. So if Mrs. B's age right now is B years old, then 3 years ago, her age can be represented by B minus 3. Since it says that she was 7 times as old as her son was then, that will be 7 times her son's age 3 years ago, which is S minus 3. So this system of equations is representing the information given in those first two sentences. In the second part, we want to use this system of equations to determine algebraically how old both Mrs. B and her son are now. And when algebraically solving a system of equations, you have two options for the method, either substitution or elimination. Substitution is a great method to use whenever one of your equations is either already solved for one variable or it's relatively easy to solve it for one variable. And in the case of our first equation here, B equals 4S plus 6, it's already solved for B, which makes the substitution method a great choice here. So what we're going to do is we're going to take that 4S plus 6 on the right side of that first equation and substitute it in place of the B in the second equation. That's going to give us the new equation, 4S plus 6 minus 3 equals 7 times S minus 3. And this is good now because we are down to just one variable, the S. Since we are down to one variable, we can solve this equation in one variable to find the value of S and see how old Mrs. B's son is right now. To do that, we'll start by combining the like terms on the left side. So we have 6 minus 3. That will give us 4S minus 3. Sorry, plus 3. And then on the right side, distribute the 7 onto the S minus 3, and we'll have 7S minus 21. If we subtract the 3 from both sides to get the constants on the right, subtract 7S from both sides to get the variables on the left, then we will have negative 3S equals negative 24. And we can divide by negative 3 to find that S is equal to 8. So right now, Mrs. B's son is 8 years old. If we want to find Mrs. B's age, we can just take this S equals 8 and plug it back into the original equation, B equals 4S plus 6. So B is equal to 4 times 8 plus 6, which gives us 32 plus 6, which means that Mrs. B is currently 38 years old. So Mrs. B is 38 years old, and her son is 8 years old. And we want to keep that information in mind. Mrs. B is currently 38 years old, and her son is currently 8 years old. The reason we want to keep that in mind is because of this next part of the problem, which is asking us to determine how many years from now Mrs. B will be 3 times as old as her son will be at that time. So if you think right now, Mrs. B is 38 years old, and her son is 8 years old. We're looking for a number of years from the current day that will have Mrs. B be 3 times as old as her son is then. So if we think of X years passing, then Mrs. B's age at that time is going to be 38 plus X. And her son's age is going to be 8 plus X. So these are going to be our 2 quantities for this equation in order to determine when this is going to occur, that Mrs. B will be 3 times as old as her son. But if we're saying that Mrs. B's age, which is the 38 plus X, will be 3 times as old as her son will be, which is the 8 plus X, we can represent that in an equation by saying 38 plus X is equal to 3 times 8 plus X. And now we have another equation with only one variable that we can solve to answer this question. There's nothing for us to do right now on the left side, but we would like to distribute the 3 over on the right. So we have 38 plus X on the left side still. Distributing the 3 on the right gives us 24 plus 3X. And if we again move the variables to the left and the constants to the right, we can subtract the 38 to move that to the right. We can subtract the 3x from both sides to move that to the left. And we'll have the equation negative 2x is equal to negative 14. And then divide by negative 2 to find that the x in this case is going to be a positive 7. Since the x represents the number of years from now that will pass before Mrs. B will be 3 times as old as her son, then we can say that Mrs. B will be 3 times as old as her son in 7 years. So in this problem, setting up the system of equations, solving the system of equations, and then setting up this equation, all of it revolves around the idea of getting the information from the problem to see how the different quantities are related. Once you have the equation set up, whether it's in the system or in this case the single equation, then you can solve and get it back into the context of the original problem for your final answer.